So hi guys, welcome back to another video. So in this video we'll be solving this problem, sliding window max. It's a hard level problem. So let's see the problem statement. Given a list of integers nums and an integer k, return the maximum values of each sublist of length k. Okay, so for each sublist of length k we have to return the max out of that. So let's see the sample input. We're given 10, 5, 2, 7, 8, 7 and k equals to 3. So length should be 3. So first 10, 5, 2. So max is 10. Okay. 5, 2, 7. So max is 7. 2, 7, 8. So max is 8. 7, 8, 7. So max is again 8. Okay. So we got this output. Okay. So let's see how we can solve this. So the first the first way in which we can solve this is we can easily traverse through every k length sublist and we can find out the max. Like we are given this. uh, okay, we are given this 787. So what we will do, we will traverse through every k length sublist. Like we will traverse through this and then through this and then through this and then through this, and for each sublist we will store the max in our answer, like answer vector. So this is very simple. We can just apply two loops. Like we will apply for this index, and then we will and in another loop we will traverse through this sublist, and then we will start from here. Then we will traverse through this sublist, then here and then here. So this is a simple approach, and the time complexity will be O of n into k, and as n and k are of the order 10 to the power 5, so it will give us really, it will exceed the time limit. So this is just a brute force approach. In the efficient way in which we can solve this, what we can do, we can use a data structure called heap. This is a data structure called heap which is represented in the form of tree. What it does is it extracts. There are two types of heap, max and meep. So it extracts max or mean, whatever heap you are using, in O of one time. And operations like insert and delete in log and time. Okay. So how we can use heap to solve this problem? Let's see. So suppose we are given this heap. We are given this is a heap, and let's take again the sample input. And then what we're going to do, we will store these elements in the form of pair. Like first will be the element and second will be index. Like we will store this, like we will store this in our heap in the form of pair. And why, I will tell you. So let's first we will store the first k elements in a heap in this form. So it will be like 10 comma 0, 5 comma 1, and let me write the index, and 2 comma 2. Okay, so and we will give priority according to our element. Like we are storing this in the form of pair, but the priority will be according to our element. Like the max will be according to our element, not the index. Okay, so and then what we will do, we will first extract the max after storing the first k element. So our max will be 10, so we will put 10 in our answer vector, and then we will apply a loop where we will start from here. So it will depict that we are now extracting out this max from this sublist. So we don't want the max from this array. Okay, like 10 is not 10 is now not present in a sublist which we are using now, which we are finding out the max from where. So we don't have to consider this 10, but how we will know that we don't have to consider this? So that's why we are storing it in the form of element and index. Like index will tell us if this element should be included in a sublist or not. It is included in a sublist or not. So let's see how we will find this. So first we'll push this 7 in a heap, so it will be 7 comma 3, and then we will apply a while loop like this. While p let's take a name of heap like pq. pq dot size is greater than 0. And what we'll do, we'll check if pq dot top will be our max, which will be 10, and dot second, which is our index. First is our element, second is our index, is less than equals to I minus k. I, because less than equals to I minus k means that is not present in our current sublist. So less than equals to I, then we will pop this element. Like we don't have to now include for further sublist this element. So we will pop this. So 10 will get popped. We will remove this, and then the second max is 7, so we'll check, and this is in our sublist right now, so we will break our while loop, and we will put this in our answer. So it says that for the second sublist the max will be 7, so we'll include this, and for the rest for this and this we'll get 10, 7, 8, and 8 similarly using this. So this is the approach we will be using heap in this problem to solve like this. And the time complexity for this is of n log n, because we're inserting n times, and for insertion the time is log n, so time will be of n log n and space will be obviously of n. Okay, so let's code this solution out. Let's solve by first method, which was our brute force. So first we'll store the size of n, and then we will make our answer vector, and we will apply loop till n minus k. Right, j is equals to I, j is less than I plus k, j plus plus, and we will first take a variable like and val equals to 0, and val is equals to max of val comma nums of j, and then we will put it in our answer, push in our answer vector this value, and then we will return our answer. So let's run. So we got accepted, but it will not pass all the test cases because it will give us time limit exceeded, as the as n and k are of the order 10 to the power 5. Okay, so we got time limit exceeded in one of the tests. So we will comment this solution out, and we will now write the efficient solution. So we'll make our heap. We don't have to create a new heap and then like we have to create the operations. We just have to use this priority queue. It is an inbuilt STL in C++. So it's we will just use this. So we will store this pair in the pair form, and the priority queue will give the priority according to this first element. So it will be our the element which is present in our array, and second will be our index. So we will first store our first key elements in our priority queue. This is a, we can call it max heap or priority queue, both are same in this form. Like first will be element, second will be index, and then we will first push back our top, which is a max element. We are pushing this first because first is the element. Then we will start from k, and first we will push this in our priority queue, and then we will apply that while loop while pq dot size is greater than 0. Sorry. And then if we will check if pq dot top dot second is less than equals to I minus k. Like this is the max right now, but it is not, we don't have to include this because it's not present in our current sublist. So we will pop this, else we will break the loop. Like we got the max and it's present in our sublist, then we will push back this pq dot top dot first again, and then we will return our answer. So let's run this. So we got accepted, and let's submit. So most probably it will pass. Okay, we got the success. So this is not, we can say, a hard problem more. It's a medium hard type of problem We just have to use heap to solve this. So thank you for watching, and I see you in the next video.